Welcome to you all. Hope that this session will give you more contextual understanding about the delaying time that is known as float of an activity in project network analysis. This video is a continuation of previous videos as a part of network analysis. This covers the following as the main sections in time analysis of project network. A brief introduction to float. A total float and example. Or other types of floats. The extended example and illustration. And the links to the previous videos. A brief introduction to float. Float or delay duration is related to the activities that are not on the main path of the project. By definition, the activities on the main path do not have floating duration. The float can be viewed into three. They are total float, independent float, and free float. In this video, these three floats are explained with examples, which can make you understand them clearly. If you find this explanation needs some more insights about float, please leave your comment to explore about it further. Total float with an example. Total float, TF, refers to how long a particular activity in a project can be delayed without affecting the total duration of the project, assuming that other activities are completed in their stipulated durations. Thus, the float of an activity, say D, can be determined in two ways. Total float of activity D, known as TFD, equals latest starting time minus earliest starting time, equals LSTD minus ESTD, where LSTD equals LFTD minus TD, so that TFD equals LFTD minus TD minus ESTD equals LFTD minus the sum of ESTD plus TD. Alternatively, total float of activity D, known as TFD, equals latest finishing time minus earliest finishing time, equals LFTD minus EFTD, where EFTD equals ESTD plus TD, so that TFD equals LFTD minus the sum of ESTD plus TD. To explore further on the total float, the network diagram of the example in the previous video has been reproduced for your convenient and continuous understanding. Accordingly, a table next is set out with the relevant available details from the network diagram below. The table consists of 4 columns, and they are activities of the project and their earliest starting time, known as EST, respective duration, and latest finishing time, known as LFT. With the available information, the table is reproduced to show you the way of determining the total float, TF, of every project activity. You can find the easiest ways of determining the total float of each activity with the formulas presented at the bottom of the table. In other type of floats, first we look into free float. Considering ESTs, the free float, FF, indicates how long a particular activity can be delayed without affecting the commencement of its succeeding activity. In this context, the FF of an activity is determined as earliest starting time of its head event known as ESTHE less, both, activity duration T and earliest starting time of its tail event ESTTE of the activity. The formula for free float of activity D known as FFD is given here. Free float FFD equals ESTHED minus TD minus ESTTED. Consider the details of activity D by referring to the previous network diagram. Here, activity D has the following information. ESTHED equals 21, TD equals 5, and ESTTED equals 10. Therefore, FFD equals ESTHED minus TD minus ESTTED equals 21 minus 5 minus 10 is equal to 6. Similarly, you can determine the FF for activities C and E that may result in 19 minus 9 minus 10 is equal to 0, and 21 minus 10 minus 11 is equal to 0 respectively. The next is the independent float known as IF. The independent float, known as IF, of an activity is referred to its float provided that the extent to which a. its preceding activities are completed as late as possible, and b. its succeeding activities are completed as early as possible. Hence, the independent float of the activity does not affect the floats of its preceding and succeeding activities. The independent float of an activity can be determined as earliest starting time of its head event ESTHE less both the activity duration t and the latest finishing time of its tail event LFTTE. The formula for determining the independent float of activity D is given below. IFD equals ESTHED minus TD minus LFTTED. To understand the independent float IF, we can consider the same information available for activity D as shown here. Consider the details of activity D by referring to the previous network diagram. Here, activity D has the following information. ESTHED equals 21, TD equals 5, and LFTTED equals 14. Therefore, IFD equals ESTHED minus TD minus LFTTED equals 21 minus 5 minus 14 is equal to 2. Similarly, you can determine the IF for activities C and E. If the IF results in negative, that is IF less than 0, then you need to consider IF equals 0. Note that the independent float indicates the possibility how an activity can be with late start, but be with early finish. For an activity, this becomes possible when its preceding activities are with late start and its succeeding activities are with early start. However, it seems mostly impossible. Hence, the independent float of an activity in a project would possibly be negative. Arguably, if an activity is with late start, it is a rare chance to finish it early. That is mostly impossible to have an activity with both late start and early finish. This is why independent float seems mostly negative, that is IF less than 0. If independent float IF less than 0, negative, for an activity, its independent float should be considered as 0, that is IF equals 0. Now we can move into an example to know further about these floats. The information on activities and their average completion durations in a project are given here in a table. Using the information, draw a network diagram for the project first. Based on it, determine the total float, TF, free float, FF, and independent float, IF, of activity D. The network diagram for the information is presented here. After completing the network diagram, you have to work on determining the earliest starting time known as EST, latest finishing time known as LFT, and the critical path, or activities, of the project. Now first, earliest starting time. Then, latest finishing time. And, finally, critical path and critical activities of the project. For the question of the example, we have to find those three types float for activity D. Required measures of activity D that are available from the diagram. EST of D equals 10. Duration T of D equals 10. LFT of D equals 50. ESTHE of D equals 40. ESTTE of D equals 10 and LFTTE of D equals 20. Using these measures and substituting them in the formula, you can find the measures of the floats for activity D. Accordingly, total float TF equals 50 minus 10 minus 10 is equal to 30 days. Free float FF equals 40 minus 10 minus 10 is equal to 20 days. And independent float IF equals 40 minus 10 minus 20 is equal to 10 days. For easy understanding of floats, the following illustration is presented for your convenience. Now you can compare all three float measures of total float, free float, and independent float of activity D at a glance. From the above network diagram and the details available, the floats of all activities of the project are tabulated here for your convenient understanding. Now you can see that the highlighted measures of activities E and F have negative values of independent float, thus equating them to 0. In this context, the table shows that independent float of activity E equals to minus 10, and that is less than 0. Therefore, independent float of activity E equals minus 10 is equated to 0, that result in independent float of activity E is 0. In the similar way, independent float of activity F is 0. This implies the impossibility for activities E and F to start late and finish early. Thank you for watching this video. If you find this video is useful and or need more clarification, you may leave a comment about your thoughts. Your valuable comments can make me produce other related videos meaningfully with your support. Thank you in advance for your comments to be made.